Okay, so we said we're going to do this question 4. So the eggs laid by female moths hatch and become caterpillars. The following time series plot shows total hectares of forest eaten by the caterpillars in a rural area during the period of 1900 to 1980, and the data is given below. So here we've got area is our response variable and year is our explanatory. Even though this is a time series, it's still still like a scatter plot because it's both numerical data. So this was our response, this is our explanatory. And they've then given us a table of values. So we know this is X really and this is Y. Okay, now they said that the association between the area of the forest and the caterpillar and the year it is nonlinear. So as soon as you see that it's nonlinear, you know that you will be doing transformations with your data. Okay, so as I said, in exams, they generally tell you what transformation you're going to do, and it has told you here a log transformation is applied to area. So really that's like saying a log 10y transformation. Okay, when the equation of the least squares line that is used to predict log 10 area is done, the slope, so they're telling you the b value is approximately that. Now they're saying to round this value to 3 significant figures. So if I just wrote that value out over here so that you can see what I'm doing, when we round to 3 significant figures, we don't start counting until we get our first non-zero number. This is our first non-zero, so 1, 2, 3. Now we look at the fourth one and it will decide whether this third one needs to be rounded up. Because it's 8, it will. So this number 3 will go to a 4. So the answer will be 0, 0, 8, 5, 4, and that's 3 significant figures. So the next part of the question is they want us to perform a log transformation on this data and find the least squares regression line for this transformed data to 3 significant figures. So we've got to put that data in and essentially get the A and the B value. They've already given us the B value really, so when we put our data in to find A, we'll be able to know whether we're correct, because hopefully we get the same B value listed there. So I'm going to go do that on our calculator. Okay, so I've gone onto the calculator originally and I put my two lists in over here, so you can see my X list and Y list here. And then I had to create the log of the area list. So here I called it LA, and then in this part I would have put L equals, and I created by going log 10 of area, and then it created this list that we can see here. I then went, because I want to find the equation, so once I've done that, I go menu, stats, stat calc, and linreg a plus bx, like we normally do, and that's to get these A and B values. So you can see now I do have a B value very similar to what they gave me there. So that is good. So I feel I've done the right thing. So I'm going to put this one in for 3 significant figures. Then I'm going to look at this A value. So it's got A equaling negative 14.396. So if I was doing 3 significant figures for this one, start counting as soon as I get a non-zero, which is straight away. 1, 2, 3. Look at the fourth one. This needs to go up. So the answer for this one will be negative 14.4. So then we move on to the next question, which is the least squares line predicts that log area in the year 2020 will be 2.85. Now the crucial part of this question is here. Using this 2.85, calculate the expected area. So what they just gave me was log 10 of the area and they said in that year, and they said it was 2.85. Now they're saying to use this data to find out what area is. So we can just put solve, and maybe we'll just call it A now, and we'll go comma A. And when we do that, we end up with 7.7 something, so it's 7.A. So the area is 708 hectares, whatever. Okay, you have to be careful. You have to use it that way. You couldn't use this whole equation down here. When you use this whole equation, you get a different number. You get a little bit, it's similar, but it's not the same. You get like, it rounds to 709. So it's close, but it's not right because they've said to use this number. So they wanted you to do that way, and that's what you had to do. So be really careful and be reading those questions. Now the next thing, the last question is this prediction reliable? This is a case of when you extrapolate, it's unreliable, and when you interpolate, it's reliable. So remember, I'm just gonna add, sorry. Okay, so if you remember back to here, we had, if you interpolate, it's when you predict within the data range. So if you were predicting a year in between 1900 and 1980, it would have been interpolation. If we are predicting outside, it's called extra. So out any year above or below. Now because 220 would be above, we would say it's extrapolation. So give reason why this is unreliable. You would say it's extrapolation. And sorry, I just spelled that wrong. Extrapolation, and it is unreliable because you're predicting outside the range of data. There you go. So I've got that from our notes there. Okay, with this question 11, Freya uses the following data to generate a scatter plot, and they've given us X and Y, so this one's pretty easy for us to do because they're telling us which is on the x-axis, which is on the y. And the scatter plot shows is non-linear, so you can sort of see that curve there, and we have to pick a transformation. As I said, in exams, they often tell you which one it is. So Freya applies a reciprocal of y. So that means she's going to create a list of 1 over y. Now, and you're going to equals something. So when you have to find the least squares regression line, you know it's got to be 1 over y equals. So I would eliminate these bottom two out of my options straight away because it's not what it is. So what you're going to do is you're going to put your lists in and create a 1 over y list and then get the equation. So I'll just pause it. Okay, so you can see I've done this in the calculator, and I created my X list and I've created the Y list, typed them in. Then I have to make up the reciprocal Y. So you can see I called it RY and then called equals and 1 over Y, and I got this reciprocal list. Then I go about to get the least squares regression line values. So I went menu, start calc, and y equals a plus bx, and you just got to be careful when you put your x list in. Well, that is x, but your y list now is the reciprocal y. Make sure you pick the transform list, and I've done that, and I've now got the a and b value. So if you have a look, this answer A is what they're putting there. So there's my A value and there's my B value. Alright, the question for 12, they said a log transformation was used to linearize a non-linear bivariate data set. They found the equation and they've worked it out to be this. Now they want you to use the equation to predict y when x equals that. So you simply just need to put x into this equation up here, and then we'll just do solve because we don't want log 10, we want just y, so we solve for that. So you can do that on your calculator. So we can do that on a calculator. I just done that there, and we can see solve, and I've popped it in and I get the answer E. Alright, so there's a few examples of transformations. Hopefully chapter 5 goes well.